Hello everyone, welcome to this tutorial on visualization and post-processing using PravaH. So here I have previously simulated a 20-layer LP web simulation. I will just click on show results and it will open my visualizer. I have already loaded the results in the visualizer. So here I can see macroscale.form which is the data file for my complete domain. And here I can see solid and liquid, which indicates solid and liquid, which indicates only the solid and liquid part. So I will delete this and we will see how we can manually extract solid and liquid from the domain. So this is my complete domain. So I can turn on surface with edges so you can see the meshing. To extract the solid from this domain, I will use the clip. So here I will click on the clip and from there I will choose the scalar because solid is my scalar, and then I choose the scalar I want to extract. So here I am choosing alpha dot solid, which is my scalar for solid, and then I will untick this invert, then clicking on apply. So it will extract my solid part, and then from here I will choose solid color only because here we for now we don't want to visualize anything plotted on the solid. So this is my solid. Let's say you want to plot the temperature on this solid. You want to see how the temperature profile is on the solid part. You will choose the temperature from here, and then you will rescale this. So this will show you your highest temperature. What is the highest temperature in your solid, and what is the lowest temperature, maximum, and your minimum temperature. Similarly, you can extract the liquid. So clicking on the clip, then I will choose the scalar. Then I will click on the alpha dot liquid. Then I will just reset this to 0.5 and then untick this invert and apply. And on this again I will plot the temperature. I will unclick this clip too, which was my solid. So now I am visualizing only the liquid part. I will reset this, rescale this. So now I can see only my liquid part. This is my molten metal, and my maximum temperature is 1808 Kelvin, and the minimum temperature is 1612 Kelvin. For this extracted liquid, I can go back to first time step. So here, and again I can rescale this. So this is the initial melt pool. If I play this, you can see the melt pool evolving with time. So here you can visualize a small keyhole forming. So here is a very small keyhole which is not too significant. I will go back to the last time step. So here is my liquid at the last time step because my cooling time was not enough for the last layer. So hence little bit of my liquid, the molten metal is remained. So yes. Now let's say I want to see the temperature. Let's say I want to plot the temperature along the length of this domain, along the height of this domain. So I will select macroscale.form, and then from here I will select plot over line button. So here you can see there are 2 points automatically generated. So I will have to adjust these points uh, so that I can extract data along the line. So here is my first point, and then I have here my last point. I will just change the background color for better visualization. Yes, so I can see the line now. So this is my first and second point for the line. So I'm just adjusting it. So this is my line. Now if I click on apply, it will extract data and plot. Here it has plotted all the variables along this line. So I will just click on this plot and come back here, and from here I can choose what variables I want to visualize on this plot. So I will just untick all and I will choose the temperature. So here you can see how your temperature is varying along this line. So you can visualize it with time how this temperature profile is changing along the line. So this for this 14th time step, this is how our temperature profile was. If I move forward, because my laser is now at this position, slowly this topmost point of the temperature will move forward because I am increasing my layer. So from first layer to I am moving towards the 20th layer. And at the last time step, I see here is my maximum temperature. So I will close this. I will delete this plot over line. So let's say now I want to visualize the uh, temperature at certain point and how it's varying along with time. For that I will use the probe. So I will go on this macroscale.form and then I will click on this probe icon, and then I will apply. So it will extract the data at some point. So we will see where is my probe. For that I will have to I can turn off this clip 1 and clip 2, and I can turn on this macroscale.form, and I can reduce the opacity of this macroscale.form so that I can see my probe, and we'll go on this probe. So here is my probe. If it's visible, I will put this probe at the topmost layer. So for the reference I can turn on the clip and also reduce the opacity. Yes. Mm, here is my probe. So I will put it on the bottommost layer. So here I have put my probe, and I will click on apply. So yeah, so here is my data. I can see 1390 Kelvin is my temperature at that point, at this particular time step. So now I want to generate the plot for all the time steps. For that I will choose this plot selection over time, and I will click on yes, and then I will click on apply. It will generate the plot for all that it will generate the plot for temperature, how it's varying along the time, right? It may take some time because we have a large data here. Here I have my plot. I can close this now, and I will click on this plot, and then I will come here From here I can select what parameters, what variables I want to visualize. So here is a nice temperature profile, how it's varying along the time at this point. So at the zeroth time, that is my first time step, the temperature at that point was very high, and then it fell down, and then it slowly increased. I can change the location of my probe. So here I can see how my temperature is varying at this probe location along the uh, time, right? So this peaks you are seeing, these are for different layers. So when first layer was when first layer was running, the temperature at that point was highest, and for second layer the temperature decreased, and then for third layer the temperature again decreased. So this shows that for the 20th layer, so here is my 20th layer, for the 20th layer, the effect of temperature on my first layer, where my probe has been put, is has been constant. I mean, there is no much effect of the 20th layer on the first layer. So this shows that your layer has been stabilized now. So, so from here I can see that the 20 layer below, the 20 layer below of my the current layer, 20th layer will have no effect of the effect on the temperature from the first layer. So I'll close this. In this graph, you can see how my temperature is varying with time at my probe location. So I have put my probe at the first layer, which is my bottommost layer. So when first layer was forming, so my temperature at that point was highest, that is 3200 Kelvin, and then for second layer the temperature decreased, and for subsequent layers the temperature went on decreasing, and then it stabilized. So for maybe for my this first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, like after 10th layer my temperature was stabilized for my bottommost layer. So there was no much effect of the temperature on my bottommost layer after 10th layer and subsequent layers. So I can close this. Now I will delete this, and we will see how we can turn on the opacity. Now we will see how we can see the velocity profile, and how we can see how my gas is moving, my shielding gas. I'm reducing the opacity of my macroscale.form, or I can just turn it off for now. And yeah, so this is my solid and liquid. Now I want to visualize the, let's say I want to visualize the shielding gas. So again I will create a clip scalar, and I will choose the alpha dot gas. I will reset this and click on invert. So, so here is my gas. So this wherever there is my shielding gas, so it will show it. So I will just reduce the opacity of my shielding gas, and here I can plot the velocity. and see how the velocity is. So velocity is very low. So I can plot the glyph for the velocity. I'll go on the macro scale, and from here I will select the glyph. I will choose the arrow glyph, and I will orient my arrows as per my velocity direction, and the length of the arrow uh, will be from the U only. And I will reset this and click apply. So here you can see how my gas is moving. So this is the velocity direction of my gas, and the gas is moving because of the temperature difference or the pressure difference, and since I have some vapor there, you can see. So here there must be some vapor. That's why we see a high velocity here. I can just plot the vapor. I'll go on macroscale.com, create a clip, scalar, and I will choose the vapor. And I scale this. So I can see my vapor here. I will reduce the opacity. So here I can see my vapor. So this is how I can visualize the velocity vectors. I'll turn off this clip, or I will delete this. Also delete this. Now let's say I want to extract the data from my results to my CSV file. For that, I will open another window here, and from here I will choose the spreadsheet view. And on the spreadsheet, if I turn on this macroscale.com, I will get all the data that I have generated. So it contains your temperature, velocity, your pressure, and the values of your alpha, liquid alpha, solid alpha, vapor, and your pressure and density. From here, I can choose the cell data because I want to extract the cell data for each cell, and using this extract button, I can save my data. So data.csv. Yes. So I have saved the data in the CSV file. I can go back, and here is all my data in the CSV form. So you can analyze this data further if you want. Now if I want to calculate some average value of this domain, let's say for the density, I want to calculate the average density of this domain. So I will click on this macroscale.form, and then I will go on filter, search. Here I will type integrate variables, and will do divide cell data by volume, so it will average out. I will click on apply, and here I will choose cell data. So here I have the average value of all the properties for the complete domain. So my average density is 5099. Now if you want to perform certain calculations, you can do that also. So go on filters, search, calculator. So here I can calculate anything. Let's say I want to convert my temperature into Fahrenheit. So I will give some name, and from here I can choose my property. So I have this temperature, and let's say I'm converting into the Celsius. I will just T minus 273. So this is my temperature in Celsius. Click on apply. Yes. So here I can see the uh, Celsius in my data. Right. So this is it for today. If you have any queries, you can write into the comment box. If you want to watch more tutorial videos, you can visit our channel. And for the Improva demo and for the queries about the software, you can scan the QR code on the screen. Thanks for watching. Don't forget to subscribe and like our channel. Thank you.